Okay, good morning. This morning I was going to start off day three, first with a very short presentation talking about the simplified source model that I'll be presenting some sensitivity results later in the talk after next. So just to familiarize those who aren't familiar with Diablo Canyon and sort of what the simplified sources are, this is a plot showing the hazard curves for PGA and for 2 seconds or half a hertz for the Diablo site. What I'm plotting here is actually normalized hazard curves. So across the x-axis, the ground motion values have been normalized by a factor. So we don't want to look at this absolute values, but we just want to look at the relative contributions of different parts of different sources. The individual sources are shown by the individual curves. The solid blue line is the total normalized hazard curve for Diablo Canyon for the two spectral frequencies that we're running. And what you can see from this is that there are sort of a grouping of sources that are sort of significant contributors to the total hazard. And then there is a clustering of other sources which contribute, but at a very lower level. And so if you look at the curve on the left, which is for PGA, you can see the red curve is associated with the Hosgri fault, which is a strike-slip fault located very close to the plant. It's about 5 kilometers off the coast away from the plant. And then you've got some other faults that are contributing, which are the San Luis Bay fault, the Los Osos fault, and then as well the shoreline fault, which is the closest fault that's very close to the site. If you then break that down into deaggregation, this is a plot showing the deaggregation at the 10 to the minus 4 level for, again, PGA and 0.5 hertz or 2 seconds. You can see, as you would expect, that the main contributor to the total hazard at the site is coming from events that are very close in distance. So across the axis here, you have the distance bins going from 0 to 3, 3 to 5, 5 to 10, all the way out to greater than 50 kilometers. And then the other axis, you have the magnitude bins going from magnitude 5 to 5.5 by half magnitude units all the way up to 8. As you can see, and as you would expect, and as probably a lot of you have already seen before in past presentations, the main contributor is from earthquakes in the, say, 6 to 6.5 range at distances of about 5 kilometers or so. That's sort of the peak of the deaggregation. These are similar results that you would get if you looked at the 10 to the minus 5 level as well. So just looking at a map view of sort of where things are relative to the plant, this is a simplified map showing the area around the plant. The plant is indicated by the red star, the Diablo Canyon plant, and you've got 4 sources that are shown on this map. And so the red source off the coast is the Hosgri fault coming through. The yellow one, the yellow trace, is the map trace of the shoreline fault, which again comes very close to the plant. The blue line on the map is the upper trace of the San Luis Bay fault, which is actually dipping underneath the plant, so it dips to the north, northeast. And then the green one is the Los Osos fault. And again, that's dipping to the southwest. And so as has been said in the last previous days, is that for Diablo Canyon at least, you're sitting on the hanging wall of both of these reverse faults. So again, the strike-slip faults are the Hosgri and the shoreline faults, and then the reverse faults are the Los Osos and the San Luis Bay fault. So in looking at the ground motion models and the sensitivity analysis, these are the 4 sources that I'll be showing results from. They're the main contributing sources to the hazard at the site. And although the source group is having their workshop 3 in 2 weeks, this is sort of the simplified representation of the sources that we're using for the sensitivity that I'll be showing later this morning. In looking at it in the terms of how things were presented on the first day here, things are broken out into the source classes for the ground motion models. So we have 2 different source classes at Diablo Canyon that are of concern. One is the strike-slip for magnitudes greater than 5, distances less than 20, dips around 70 to 90. And that would, of course, be the Hosgri and the shoreline faults. And then the other case is the reverse faults, magnitudes greater than 5, distances less than 20. And again, we're on the hanging wall. And so as it has been said in this workshop, the ground motion models will probably be developed for a hanging wall site because we don't have to worry about the footwall site at Diablo Canyon. And again, those 2 sources that are contributing are the Los Osos and the San Luis Bay faults. Finally, my last slide, which is very quick this morning, we'll be talking about the base case. And I'll go into a little bit more detail of this in the next presentation after Bob talks about the logic trees. And that's looking at what is the base case. And Melanie presented some results for Palos Verdes, but I'll be doing the similar thing For the most part, the base case will be looking at using the 5 NGA 2008 NGA West 1 models as sort of the reference. They're given equal weights. The VS30 that I'll be showing is all for VS30 of 760. Associated with that, the Z1 and Z2.5 terms will be the default values for the models that require those. And as well, I'll be using some epistemic uncertainty, which is the same model that was used in the shoreline report. So that's going to be my base case that I'll be showing sensitivity results for, so the hazard curves and as well the tornado plots. The one caveat to that is that for some of the cases, the sensitivity cases that I'll go into more detail, is I didn't use the published aleatory sigma values, but I fixed the sigma at a fixed value of say 0.65. And when I go into the sensitivity analysis, I'll talk about those and highlight those specifically such that we can sort of isolate in the tornado plots individual features that are coming through in the models. Any questions?